It's a day today. Yesterday, yes. All right, we're on this part again, so I'm glad that brings back. All right, so we were working with our calculator yesterday. All right, for those of you guys who were not here, who missed it. All right. Good information. All right, now I started getting frustrated because some of you are not listening to me. All right, and I'm saying, you know what I mean? I don't have the ability to put it right up there on the screen, right? So you have to kind of listen. And if you don't understand what I'm saying, you just have to tell me right away. All right, it's frustrating when I'm 5 steps ahead and you're now telling me you don't know how to do something. All right. So anybody have any issues? Anybody have any issues? All right. So we need stat, edit, L1, L2. And then we had Zoom stat, which we said was 9, correct? And then everybody was able to see those points plotted. So I agree with that. And then the bell rang. All right. So, hey, is yours working? You know what to do? All right. So you got it up there? Oh, yeah. Perfect. Okay. So now with that, all right, now I would like to write the equation of that line. Is everybody with me? All right. So in order to write the equation of the line, you would now have to hit stat. Everybody hit that button. Then we want to calculate. So you go over to the right. I think it's 2 spaces. And then a bunch of information comes up. And on there, I think number 4 is line reg or something like that. That just means drawing. They call it a linear regression, basically a line of best fit. All right. So what you want to do is you want to hit number 4, and then you just hit enter all the way through. And then that calculates the line of best fit. So someone tell me what they got for the line of best fit. Tell me.
A equals 25.7.
Okay.
B equals negative 491.
Plus or minus, did you say? Minus what? Okay. So there you have that. All right. I mean, if your numbers came up different, they shouldn't be that much different. All right. Unless you accidentally type something in. Is everybody okay with that? All right. So now what I want you to do is go to y equals. And now you're going to type in that equation. So everybody go to y equals and then type in 25.7 x minus 191.5. And then hit graph. And does everybody see the line comes up now? And it should try to go through those points. Is everybody agreeing with me? Now remember, I get more frustrated if you don't tell me you're having a problem than if you just sit here and not know. All right, so I know the calculator is, can be a little bit annoying. All right. Yes. You hit Zoom. Zoom 9. Hit 9 now. You with me? What? Now so now Sebastian asked a good question. So now what? All right. Now listen, Cooper, listen, I'm sorry you're a little behind or whatever, but you know what I mean? There's no way for me to explain it right now. All right, especially if your calculator's not there. Do you not is your calculator not being
No, it's not like I don't even know, it's not turning on.
Right, because it's not charged. Right? That's why it doesn't turn on, because it wasn't charged. All right. So you gotta come back here and charge it for a little while or do whatever. And then at some point you need to figure this out. All right. But now on your screen, there was a bunch of dots, right? And then you had a line go through it, right? So it's trying to show you that's the prediction of what will happen. All right. So on here, it's saying after we do the line, make a prediction about 2018. All right. Now, for 2018, does everybody agree we didn't put 2000 in? So what number do we type in for X? 18. All right. Now, just because you're super smart, X equals 18. I want to figure out what the Y is. We could just plug 18 into this right here. Do you agree? But now I'm trying to teach you how to use your calculator. So now I need everybody hit second. and then graph. And does everybody see your table comes up? What do I want X to be? 18. So you can either scroll down to 18, or if it was still there from last year, you can just type in 18 and it'll tell you the answer. All right. And what is the answer? What's the prediction for 2018? There will be what? 271 million users. All right, 271 million. Now, guys, that is an important thing to understand how to use your calculator on. All right, that's super important. We did it last year. All right. I don't expect anybody to remember it, but now you're getting wiser. You're supposed to understand the calculator a little better. All right, so let's make this clear just so I can say. When you want to plot points, you go to Stat Edit, and then L1, L2. You plug in the X and the Y values. Then you need to calculate the line. So you go to Stat, click over to Calculate, and then you do the line. And then it calculates that line of best fit for you. You use that line then to make predicted values for whatever you want X to be. All right. Now, again, I understand that's not an easy thing to do. All right. But I think if you understand the process, I don't think it's that bad. All right. Now, the last thing I want to tell you is sometimes stat plot messes up your calculator, because now if we try to graph something, it's trying to plot points as well as graph. Right. So once we're done plotting points and we're done with plotting points, it would be smart to turn that off. So how do you turn it off? You just go to Y equals, you go to the above, and where it's dark, click it, light. And now if you go back to graph, the points are what? The points are gone because you told the calculator to stop plotting points. If you want the points back on, you just turn it on. All right. Yes. Yeah, plot 1. There's also a plot 2, there's things that you can do, more complex things that we don't care about right now. So it's just plot 1 that we're interested in, turning that off. All right. So now again, I feel strongly that that is super important. All right. So we'll be writing lines of best fit throughout the year. All right. And I want you to be able to do that. And soon I'll show you how to draw all the different types of graphs, or your calculator has the ability to figure out what the graphs are quickly. What? Well, the graph was done on the calculator. I don't care about the graph, right? I kind of trying to draw it off to the side a little bit. I don't really care about that. The calculator does all the work for you, is essentially what we're trying to show you. Okay. All right, so now I'm going to work down the page, probably spend 15 minutes. If some of you guys did some of these problems, and I appreciate that, and you're like, would you help me with this one? I'll be happy to do that. I don't want to, but I also feel like this is kind of important, so I want to go through this. All right, but let me just start out with 12 and 13. I want to finish that up, and then we'll get to the regular problems. All right, so now find a counterexample. Remember, a counterexample is just a statement to prove that the conjecture is false. So it says if A and B are complementary, then they share a common side. Does that have to be true? No. Any 40-degree angle is complementary with any what? 50-degree angle. They don't have to be. When they say share a common side, I want you to remember it's adjacent. Now, I feel as though the test results were not as good because we don't understand the words. Is that a fair statement? Right? I believe that's true. I could be wrong, but I feel that's fair. So if I say adjacent and you have no idea what we're talking about, you can just say to me, man, will you just say to me what adjacent means again? All right. And then we will describe what adjacent means. All right. Now, some of you I do get frustrated with. I'm going to be perfectly honest because you're not listening to me all the time. All right, you're doing other things. All right, so that's my frustration. All right, stay engaged and I don't have a problem. All right, what's your question?
Can you tell me what adjacent is?
Adjacent, the definition of adjacent is two angles that share a common ray. That's the formal definition of adjacent. I don't really care about the formal definition. I just want you to say these two angles are adjacent because they're right next to each other. Does that make sense? That's what adjacent means.
Thank you.
All right, right next to each other. All right. And so that's what they're trying to get at when they say share a common side. All right, let's look at 13. If a ray intersects a segment at its midpoint, then its ray is perpendicular. Does that have to be true? No. And some people just automatically assume that that has to be true, right? But if you're at the midpoint, and again, every single time, the only way I got better at it was to draw, and so I could see all the different options. This right here would be a midpoint. I can draw that, right? Is that perpendicular? No. Can I draw it so it is perpendicular? Yes. That's the problem some of you had. Narrow-minded. You're only thinking about one particular option. When you take a test, you should try to do, instead of trying to make it true, you should try to what? Make it not true. Try to make it false. That's exactly what you're trying to do when you draw pictures. All right. That's the objective. All right. And then you can start to see more things. All right. Now I finished off. Generally, if I can do the first part, then the practice and problem solving is supposed to be a repeated process. So once again, I gave you specific numbers. I don't really care about the patterns so much. I mean, you're supposed to be able to recognize patterns pretty well. But is there anything in here that somebody's just like, I have no clue? What?
What was the pattern for 18?
So anybody tell me this pattern? What is it? So she's saying you add 3, and then you add 5, and then you add 7, then you add 9, correct? There's a better one. Who can tell me? Ooh, you're adding primes? No, because 9's not a prime. What else?
You just added like 2 to, it's kind of like 85.
But again, you'll learn as you go further into math. Yeah, you should just recognize 1 squared, 2 squared, 3 squared, 4 squared. Everybody see that? 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, correct? But what Katie said was absolutely correct. You can also describe it as adding odds, which is very strange. All right, very strange. Does everybody see that? So the next one would be 25, and if you add 11, the next one would be 36. It's weird how numbers form patterns, all right? And then you can describe the numbers based on the pattern, all right? It's really fascinating, all right? So, all right, that was a very good question, actually, all right? Now, I'm never really going to ask you questions about these patterns. I don't care about those. You're never going to have to draw the next one, so what? Which one? 20. So what am I doing on 20? Oh, I know. Subtract what?
2:30.
Yeah, 2 hours and 30 minutes, right? We're just decreasing by 2 hours and 30 minutes. Make sense now? All right. So let's continue on. All right. Was anybody on here? Does anybody want me? I gave you some problems to do, and you know what I mean? Hopefully you kind of looked through some, and if some were hard, you got to tell me. Anybody have any issues with these? 40 through 45. Let's just look at those. Determine whether each conjecture is true or false. Give a counterexample for any false conjecture. If n is a prime number, then n plus 1 is not prime. That's a great problem.
No, because 1 and 2.
Okay, I like that a lot. But listen to me. This is on a lot of standardized tests. Is 1 a prime number? No, 1 is not prime. It's not composite either. It's weird. All right. So 1 is not considered, but still you're correct, because it's not 1 that you should be starting with. It's what? 2. Right. So it's definitely false, because 2 plus 1 is what? 3. All right. If n is a prime number, then n plus 1 is not prime. All right. So that's the counterexample for that. That's the counterexample. Does everybody agree with that? Because every prime number besides what number? 2 is what? Odd, right? So if you add 1 to an odd, it becomes a what? Right, so that was kind of tricky, okay? It seems like it should be true. All right, what?
Can you help me on 35?
Not yet, 41. All right, I said we're gonna do 40 through 45 real quick. All right, 41, if X is an integer, then negative X is positive. That's obviously what? False. I've been trying to tell you for the longest time, just because the variable is negative doesn't make it negative. You should know that. That's on a lot of standardized tests as well. All right, so that was good. If angle 2 and 3 are supplementary, then angle 2 and 3 form a linear pair. That's the same as what we just talked about with the what? Two angles being complementary, sharing a common side, right? So that doesn't have to be true, right? You can draw this is a linear pair. Does everybody agree with that? That's a linear pair. All right, now I can just separate it so it looks like this and it looks like this. Now it's not a linear pair, but they're still supplementary. All right, everybody should be able to do that, right? And I honestly feel like if you're not trying these on your own, then you're not getting better. If all you're doing is listening to me explain them, you're really not getting better at it. You have to try it on your own, as annoying as it is. And I know it's annoying. All right, trying to figure it out. All right, you have to try on your own. Yes.
I'm not touching, so are they supplementary?
If this is 150 and this is 30, are they supplementary? Now, do you understand?
Does it matter how close they are to each other?
I don't know what you mean.
Can you put
Closeness has nothing to do with supplementary. Supplementary means two angles have to add up to what? 180. Do you agree with that? This is special because it says it's a linear pair. Now, a linear pair means it shares a common ray, which means adjacent, and it forms a line. You with me on that now? All right, those are the definitions. All right, if you have 3 points A, B, C, then A, B, C are non-collinear. That doesn't make sense, right? That was easy. That's definitely false. If in triangle ABC, AB squared plus BC squared equals AC squared, then it's a right triangle. Obviously, that's what? True, because that's the Pythagorean theorem. A squared plus B squared equals C squared. If that's true, it's a right triangle. 100% of the time. All right, and then 45. If the area of a rectangle is 20, then the length is 10 and the width is 2. Definitely what? False, right? You can have a rectangle with an area of 20 that could be 1 by 20. Does everybody agree with that? 4 and 5, lots of different things. It doesn't have to be 10 by 2. And that's why I'm saying for those guys, if you thought that was true, that just means you're not thinking of all possible outcomes. And like I said, that's the hardest thing in geometry, thinking of all the possible outcomes. All right, so now Tanner, what? 35? You think. Which one are we doing?
35.
All right. The relationship between AB and the set of points equidistant from AB. So we're going to draw AB. And then the set of all points that are equidistant from AB. All right, so now I'm not expecting you, this was hard. So is that point equidistant? Right, because I made it equidistant. And so then I'm going to put this point right there. Is that equidistant? Yes. All right, I'm trying to draw equidistant. Now, this would be considered the what? Midpoint. And all of these points, I'm trying to make the same distance. All right, so now if I connect all these points, what does that line look like it's doing to segment AB? Thank you. It is definitely perpendicular. It also what? That's exactly correct. All right, that's a big unit. All right, it's a big unit. I'm not sure why they would throw that in there, but I appreciate you asking me that question. All right, so the description of that would be, that is the perpendicular bisector. And I'm not expecting anybody to know that, all right? You would just draw those dots like I did. And if you would draw those dots, you might be able to see something. All right. But you're not supposed to just look at that and say, oh, that's the perpendicular bisector. Nobody does that. If you don't draw it out, it's difficult to see. And the sooner you start drawing things out, the better it becomes, the easier it becomes. All right. Is everybody okay with that? All right, we spent a lot of time on this. All right, does anybody, I feel like making this graph here, but I don't think we have time. All right, does anybody want me to say the steps real quick? Does everybody know how to use them? All right, so this is important, so I'm going to go ahead and do it one more time. Everybody do it. We'll just do it together. Pull out your calculator. Quickly, quickly, quickly. All right, the first thing I need you to do, all right, hopefully you're working a little bit now, Cooper. All right, hustle up, hustle up. And if you want to sit back there and just do it, that might be, all right. Here we go. All right, so now I need to clear a list. We don't delete a list or there's problems. All right, so to clear the list, everybody's going to stat edit, right? Stat edit. Then there's numbers in your list, correct? So you go up to the top of the list, hit clear, and then push the button down. And magic, all the prompts or all the data points go away. Does everybody hear me? So now you go over to L2, go up, hit clear, go down, and now it's cleared. If you have short-term memory issues, right? If you have short-term memory issues, you should be doing what to these steps? Writing them down. All right, that's what you should be doing. All right. So now the list is cleared. Now, in L1, what numbers am I going to put? 9, 10, 11, 12, 13, 14, 15. We don't need to put 2,000 in there. If you want, is it okay to put 2,000 in there? Yes, it's okay. All right. Then under L2, hey, are you with me? I'm doing it for you now. Where's your calculator? You got it?
Yeah, I can.
Then you need to speak up. This is what I'm talking about. I'm specifically doing this for you. Please tell me, jump in. You listen to me. I know I'm loud sometimes, right? I want you to tell me, hey, come on, man. I wasn't here for a couple days. Help me out. All right. What are we doing? Did you go to stat?
Yes.
Did you go to edit?
Mhm.
Does L1 and L2 come up?
No.
Come here. Bring me your calculator. Hurry up. Now, while I'm fixing his calculator, everybody's going down. All right. Stat, edit, L1. Get busy. All right. Now, I really appreciate looking at the data. All right. So we need to turn on stat plot, turn that back on if you turn it off. All right, but hold on, I'm waiting for Aiden. Sorry, Aiden. You typing the numbers in, right?
Yeah.
All right, finish typing them in. 9, 10, 11, 12, 13, 14, 15. Are they? And tell me when you're ready. Okay, now what we're going to do is I need you to be able to tell the calculator to turn on those points, right? So I need you to go to Y equals, and at the top, there's a stat plot button. You with me? You go above it and click it, and it turns black. Now your calculator can plot the points, right? Now, unfortunately, the points are off the graph, right? So now we have to go to zoom and then stat. And zoom stat is number 9. Now all the points come up on your screen. Is that true? Okay. Now we need to go to zoom, not zoom, sorry. We need to go to stat. And then we go over to calc. And does it form a line? Are the points making kind of a line? I'm asking, show me. Yeah, they kind of make a line. All right, but not perfect, right? If you do data, everybody should know it's not going to be perfect, right? So then you go to stat calc, and you go down to number 4. then you hit enter all the way through. The calculator is calculating the absolute best line of fit. So what, somebody tell me what their calculator came out to be. Go, Oliver. Exactly one. Just tell me 1 point what?
0.85.
Yeah, I don't want it rounded. I want to know what's on your calculator. I want everyone else to know if they got the same thing. So it's approximately point, let's go to 3 decimal places. 0.85 what? 0.986. Is everybody something similar to that, right? So now go to y equals and type that in. Y equals 0.857x minus 7.986. And then when you graph it, it should kind of mirror those points the best that it can. And you're supposed to go, wow, okay, that's pretty cool, right? I know some of you, it's not the coolest thing in the world, but for me, it was amazing. All right. It's not supposed to go through every point. Is it possible for it to go through every point? No, because they're not collinear, right? Now that we have all that, all right, there usually is a question about a certain date or something. Make a statistical graph, make a conjecture based on the data and explain how you, well, I don't even care about all that. I just wanted practice. All right, is everybody good with that? All right, now what did I tell you about graphing and plotting points if we forget to turn it off? It'll mess up your calculator sometimes. It'll say dimension mismatch error. All right, so you need to go back to stat plot. If it says dimension mismatch error, that just means it's having trouble with what you're telling it. So turn the stat plots off, and now you're golden. All right, you know everything there is to know about graphing, plotting points, making line of best fits, and then educating, you know, whatever the question is, you have to calculate whatever. All right, so I'm totally happy with that. All right, now, because I have so much work to do, right? Now we're just going to continue right into the next lesson. I appreciate it. Hold off on this homework. Just put it up for me. All right, I will calculate it as all complete. All right, and I don't have time. So what we're going to do now is I need you to open up the new note, please. All right, part of the reason why I put the new note in was because there's a lot of just fascinating things, all right, coming your way. It's probably going to take me some time here, and there's some interesting statements in here. Now, I know it's been a while, right? I never really read things to you, but there's some things, if you don't pick up, you're just not going to know, all right? And you're going to miss everything. So this is important. So I made a note for you, all right? So you could highlight as we're going and make sure you're understanding. There's all kinds of cool symbols. And this looks so hard, but in fact, it's so what? It's so easy. But when you look at the symbols, you're going, oh my gosh, that person's really smart because look, they have symbols, right? It is really simple. All right. But you've got to understand the symbols in order to continue with the lesson. All right. So is everybody ready? Let's go. All right, I'm looking around. Some people are still not with me. All right. This was a file put in Google Classroom, right? I didn't want you reading out of the book. I want it so you can study when we have a test. You can look at this page and figure out things, all right, when you forget them. All right, and there's just a lot of information, a whole lot. All right, so here we go. A conditional statement is a statement that can be written in an if-then form. All right, so conditional. If somebody says if, then this will happen, that's called a conditional statement. All right, some of you probably already know that. All right. Now, if what is after the if, that is considered the hypothesis. And if that hypothesis is true, then what? Then the conclusion must be true. Is everybody with me on this? All right. Now, in math, all right, we represent words with symbols. So instead of writing all that out, we just abbreviated everything. All right, we called the hypothesis P and we call the conclusion Q for some strange reason. I have no idea why. And if it's conditional, they use this arrow, if then. Is everybody with me on that? All right. So we can just label this as P, we label this as Q, and then it's a conditional. So we say if P, then Q. That's how simple it is. Looks complicated. There's nothing more to it than that. Please listen, or in a few minutes as I go down the page, you'll be thinking this is a nightmare, and it's really not. All right. Anybody have any issues with that so far? Easy. All right. So that's the first thing. All right. Now I'm scrolling down. There's just some examples. And then you are asked to convert them into if then. All right. Statements. All right. Now for me, you have to decide what is the hypothesis and what is the conclusion. Notice in this example right here, the conclusion can be written second. I'm really not going to do that to you for the most part. I think in the example problems, they sometimes do, right? But again, sometimes I think it's unclear. All right. I definitely think it's unclear. All right. But you can see points will be deducted from any paper turned in after Wednesday's deadline. So they want to write it. If a paper is turned in after Wednesday's deadline, then the points will be deducted. Does that make sense to everybody? And again, there's just nothing I can do to explain that better. All right. Is everybody with me? All right. Okay. So now we kind of work down here for a couple of the examples. All right. A mammal is a warm-blooded animal. If an animal is a mammal, then it is warm-blooded. That's how you're going to write it as a conditional. A prism with bases that are regular polygons is a regular prism. Does everybody see that? I mean, I don't want to bore you to death with that. So let's move on. All right. So now here is the important stuff. Sorry, it's all right. To show that a conditional is true, you must show that for each case, when the hypothesis is true, the conclusion is also true. To show that a conditional is false, you only need to show, or you only need to find one counterexample. Okay, so now here's where I was mystified, and I argued with my teacher all the time, and I told him I thought it was just the most ridiculous thing I ever heard of, and I still think it's ridiculous, and I don't even understand why, right? So listen to this. All right, this next thing. I understood this part. The first part was totally understandable, right? I understand that. Now, the next part, I had no clue who's making this stuff up. All right. Did I make the rules? I don't make the rules. All right. And this is called logic. All right. And I don't know why it's this way. It doesn't make sense to me. But the next sentence you need to listen to and see if it makes sense. When the hypothesis of a conditional is not met, the truth of the conditional cannot be determined. All right. Let me say that again. When the hypothesis of a conditional is not met, the truth of the conditional cannot be determined. So if I don't know whether it's true or false, I would say it was what? I would say it was false. That would be logical to me, right? But they're saying what? When the truth of a conditional statement cannot be determined, it is considered true by default. If a statement is not false, logic dictates that it must be what?
True.
Right? So again, I had lots of problems. I missed lots of questions on a test because I never knew that. Or I didn't understand it, and it doesn't make sense to me. If I can't prove whether something is true or false, then the statement is automatically what? It's automatically true. That's what it's telling you. All right. Which doesn't make sense to me. All right. I totally disagree with that. But I didn't make up the rules of logic. I've looked it up. I've tried to figure out why. I can't even find someone that can explain to me logically why that's necessarily true. All right. But someone tried, and I tried to understand him, but I didn't understand it. So again, some things I've learned I just have to accept as true, even when I don't like it. All right. So for our discussion, if we don't know the truth of something, then it's automatically what? It's automatically true. All right. So with that being said, if you can divide an integer by another integer, the result is also an integer. That's obviously a what statement? Come on, guys, help me out. It's definitely false. And I mean, if you just read below, it's telling you, right? So I'm not asking you to jump out on a limb or anything, right? And it's obvious. I say 1 divided by 2. Is 1 divided by 2 an integer?
No.
No, it's not. Integers are counting numbers and they're opposites, right? So 1/2 is not a counting number. So that's false. All right, let's look at B. If next month is August, then this month is July. Would you say that's true?
Yeah.
Right? When the hypothesis is true, the conclusion is also true. Because August is the month that follows July, the conditional statement must be true. Is everybody with me? All right, now here's where I was hoping you need to listen. If a triangle has 4 sides, true or false? So to me, it should be what? A triangle doesn't have 4 sides. How can that statement be true? But again, if you're like me, you're going to miss a bunch of questions on the test because obviously that's false. Is that us, really? All right. So hold up just 1 second. So because that's first statement is false, the conditional is what?
True.
Yes, some of you are not listening to me. You're going to bomb the test. I guarantee it. If the hypothesis is false, the conditional is true. I know it doesn't make sense. All right, so we will pick up right there tomorrow, guys. Thank you very much. That was a great day. Thank you.